Hey guys, today we are going to discuss the topic of one-way slabs of the subject Elementary Structural Design 6M Civil Engineering. Myself, Assistant Professor Gaurang Prajapati from Civil Department, MGT College, Navsari. Let's start with the introduction. A slab. A slab is a plate element having depth very small as compared to its length and width. Means the depth of the slab is really very small. A slab is used as floor or roof in the building and carry uniformly distributed loads, that's UDL. Slab may be simply supported, continuous or cantilever. Now, types of slab based on the support condition. Basically, slabs are categorized under the four different categories: one-way slab, two-way slab, flat slab which rests directly on the column without the beams, and the fourth, grid slab, or we can say waffle slabs. Starting the first category, that is one-way slab. If the slab is supported by the beams on two opposite sides, it's called the one-way slab. Okay, let's see in the figure. See, these are our two supports on which the slab is resting. These supports are nothing but we can say it's beam. In this type of slab, loads are transferred on two opposite directions, or we can say two opposite supports. Say this is the center line, then half the load of the slab will be transferred on this support, while the load of the slab will be transferred on particularly this support. So condition for one-way slab will be Ly by Lx greater or equals to 2, where Lx is this shorter length while Ly is this longer length. Now, for any slab, if Ly equals to Lx, for example square slab, the slab has a tendency to bend in both the directions. Means slab can bend either along Lx or we can say along Ly also. But with increase of Ly, the tendency of bending along the Ly is reduced, while along that of Lx is increased. Means slab can bend along particularly this Lx directions, that is the short directions. So when Ly by Lx greater equals to 2, the slab bends only in the x direction, so the main reinforcement is provided along the short direction, that's along Lx. So when this kind of ratios occur, we can say Ly by Lx greater equals to 2, the slab is called the one-way slab. Now over here we can see in the figure, see this one, say this is our Lx while this is our Ly. Now the main steel is provided along the Lx. Over here we can see that main bars are there, okay, that is along Lx, while this one, say I am talking about particularly this bar, these are the temperature reinforcement, or we can say the distribution steel. Now what does distribution steel do? Distribution steel doesn't carry the load by itself, it transfers the load onto the main steel. Means we can understand it over here. Say this is our main bar. Now distribution steel will be say like this. So whatever the load comes on this particularly distribution steel, it will transfer its load to the main reinforcement. So that's why main reinforcement is the main element in case of the one-way slab. Now second category, two-way slab. If the slab is supported on all four edges and if Ly by Lx is less than 2, then it's called the two-way slab. Over here we can see these are the four edges on which the slab is supported, okay, and it is vice versa. Then one-way slab, in case of one-way slab it was Ly by Lx greater or equals to 2, while here for two-way slab Ly by Lx is less than 2. The tendency of slab is to bend in both the directions, so such slabs are called the two-way slabs. And in two-way slabs, as slab can bend in both the directions, main reinforcement is provided along Lx, that is shorter direction, and along Ly also, that is along the longer direction. Third category, that is flat slab. When the slab is directly supported on columns without beams, it's known as flat slab. Now in case of flat slab, beams are not there. We can see over here in the figure, slab is directly supported on columns. We can see over here there is no beam in between them, okay. Flat slabs are provided to increase the floor height and to permit large amount of light which might be obstructed by the depth of beams. Means when we need higher floor height, then in such cases we could provide flat slab, which will omit the beams. Fourth category, that is grid slab. When the slab is supported on beams with columns only on the periphery of the whole, it's known as grid slab. Means in other words, we can say we can provide the beams that is of larger depth beams, but we cannot provide the columns in intermediate. That is means we can provide the columns that is over at the border, or we can say at the periphery. Now as we can see over here, see, these are the columns. Those all are provided along the periphery, not in between of the span. So sometimes in large halls, public places, marriage halls, auditoriums, etc., a large column free area is required just because of the larger gathering of the people. In this case, larger deep beams may be permitted, but the columns are provided only on the periphery. The grid slabs may have rectangular grid, or we can say diagrid. Now, the difference between the one-way slab and two-way slab. Now, the basic conditions for the one-way slab is Ly by Lx greater or equals to 2, while for two-way slab Ly by Lx is less than 2. Second, for one-way slab, the bending of the slab takes place only along the shorter direction, while in case of two-way slab, bending of the slab take place in both the direction. In case of one-way slab, main reinforcement is provided along the Lx as slabs bend along the shorter direction only, while in case of two-way slab, as slabs bend in both the directions, so we need to provide the reinforcement along both directions. For one-way slab, depth required is quite more, while for two-way slab, depth required is quite less. Fifth, for one-way slab, as the thickness is more, the amount of the steel required is also more, and so it is the less economical. While in case of two-way slab, as the thickness is less and the amount of steel is also less, it is economical. Now the difference between the beam and the slab. Now slab is analyzed as 1 meter wide beam. We can see over here, it is analyzed as 1 meter wide beam. Normally the compression reinforcement is not provided in the slab, as slab is the tension structural member. There is no need to provide the compression reinforcement in that one. Shear reinforcement is also not provided in the slabs due to the lower shear stress. Then temperature, or we can say the distribution reinforcement, is provided perpendicular to the main beam. As we discussed in the earlier slide, distribution steel just transfers the load on the main beam, while the thickness of slab is very small as compared to the beam. Now, minimum reinforcement requirement for the slab. Now, the minimum reinforcement requirement criteria is the minimum equals to PT minimum BD by 100, where B, that is 1000 mm, as slab is analyzed as 1 meter wide beam. D, that is overall depth of slab, while PT minimum, that is 0.12% for Fe 415 and Fe 500, while 0.15% for Fe 250. It is given in the code IS 456, clause number 26.5.2.1, page number 48. Now let's understand the reinforcement criteria in the figure. Now as we can see, say plan is there, that is Ly by Lx. Lx is the shorter direction, Ly is the longer dimension. As we discussed in the previous slide, it is analyzed as 1 meter wide beam. So if we take a section AA over here, so over here, so section A is there along the Lx. Now as the main reinforcement is provided along the Lx like this, if we see from this direction, we can see a straight line only as a main shield, that is over here. It is denoted by over here, and it is bent up at the distance of L by 7, or we can say 0.15 L from the center of the support. Okay, while these dots are, we can say, the distribution steel, that is over here. As we discussed earlier, this one is our main steel, while this is our distribution steel. If we see along the Lx direction, as per the section A, we will see a straight line that is as a main steel, that is this one, while dot dot, that is as a distribution steel. Okay, so hope you guys get the basic concept of the one-way slabs through it. And lastly, bars are bent up near the support just because to prevent the uplifting of the support. Okay, thank you.